GrowthPoint has done the two largest M&A transactions in the simulation for training and AI learning markets. We just signed a deal between the large Swedish high-tech engineering company Sandvik and Thoratec from Durban, South Africa. This transaction is the next generation and more indication of the importance of simulation as a path to AI in the world of heavy equipment and its use in heavy industries, such as defense, mining, emergency services, forestry, manufacturing and construction, for example.
So a couple of years ago, we did a similarly interesting transaction, a company in Perth, Australia called Immersive Technologies. We did a transaction with Komatsu in Japan. Like Thoratec, Immersive Technologies also had a very powerful simulation engine, which was software that drove simulation equipment that allowed operators in mines and construction sites to be trained and therefore have less accidents. The economics behind this is if they have an accident in a mine, usually shuts the mine down for a few days and costs tens of millions of dollars. Well, the simulation allowed people to train, and so they were better at driving the equipment in the field. Well, the reason this is strategic is because in the future, and in the not too distant future, they're trying to take all the people out of mines or all the people out of danger zones on an oil rig or in a construction site or something like that, because the cost of losing a person is just astronomical in these environments. So what's happening is there's a lot of technologies being developed for simulation that are enabling what's called remote operation. So before you can actually do an autonomic vehicle, which is really a robotic truck or a robotic crane or a robotic shoveler, and figure out how that they can operate without any person involved, they need to go to remote operation where the person could be sitting in a different city or a different, part of the mine, or maybe in the town that they've built next to the mine to support the mine. And those people can then operate the equipment by sitting in an almost identical vehicle, but it's simulated. And they're really controlling the actual vehicle, which is, a few miles away. And that's a precursor to being completely robotic. Well, so there's several things involved in that, right? Think about it as you're in a simulated environment, but you actually are operating as though you're in the remote environment. Well, you have to capture that remote environment. So there's a lot of camera technology involved and ingestion of that camera data and processing of that camera data, ingesting the terrain so that as you're remotely operating, you feel the bumps that remote vehicle is going through. And so the sort of next phase in terms of making this completely robotic is to take the person out of the cab, put them in a remote place and make that remote place feel and seem and behave identically to the mine itself. And so there's a company called Ultrasim that actually is very good at ingesting remote places, whether it's an operating theater in a hospital or a construction site or a mine. It can essentially create a very accurate 3D rendering environment and then bring that into, in order to be able to move around it seamlessly, you have to bring it into a gaming platform like Unity is a good example of a gaming platform that allows you to move very realistically in that 3D virtual environment. And then the next step of that is to put objects into those places. So whether it be a truck or a crane, those objects interact with that virtual environment, and that requires a lot of mathematics to calculate the physics involved. There's a great company in Montreal called CM Labs that has an amazing physics engine for actually making water appear like it's behaving naturally, or when you move soil, if you're digging in a construction site, it makes it look like identical to how it would actually look. So what we're seeing in terms of simulation is that simulation technology starts out with training people to use equipment, moves to sort of remote operation, and then in addition to remote operation allows you to find things in that environment that have sensors on. But then where this is going is that in order to develop autonomic technologies like robotic cranes, robotic trucks, or robots that operate in a hospital, for example, you need to be able to develop and test in this virtual environment. And so simulation is going to be used in the not too distant future to help create robots or autonomous equipment to take the risk of having accidents out of the economics of running these businesses, and therefore save just vast amounts of money that are currently lost in oil and gas, construction, mining, forestry, ports, loading and offloading ships, firefighting, defense. And you can think of a lot of these industries that are prone to accident and prone to having significant downtime costs, benefiting dramatically from these simulation environments. And we're very excited about simulation. We think it's going to be an exciting area in the next few years.